Hello and welcome to this G-Audio tutorial on custom filters. This is G-Audio's mixer right here. It's very straightforward to add or remove filters to both mono tracks and to the master output. You can select a filter from a built-in list of filters and just click Add Filter. You'll have a few sliders to play around with and the choice to bypass the filter on every single filter type. It's also quite straightforward to get your own filters to show up in the mixer inspector so that you can add them just as built-in filters can be added. I'll just show you how to do that right now. I'll create a new C# script. Name it example filter, open it up. Now I'll use the GAT distortion filter as a template. GAT distortion is the simplest of G-Audio's filters, so it will be a reasonably easy template to adapt. Notice that we do need to use the Unity editor namespace for your filters to show up in the inspector, but that is wrapped in a if Unity editor pre-compilation directive, so it won't be a problem. The first thing you'll notice also is this interface declaration. Every filter needs an interface for its controls. We'll call ours example filter and get rid of the second property, and we'll just keep the threshold property. This property has a custom attribute that will be used to draw the slider and will actually be the range of the drawn slider in the inspector. I'm setting it to a very tight range. You'll understand why a bit later. I'm about to make a very silly filter. The class or class is example filter, and it extends a GAT monofilter and implements its control interface here. It has the initialize on load attributes because we want its static constructor to be fired as soon as you load Unity, so that the filter can register its existence and show up in inspectors. Now, the first compulsory override here is the control interface type. That's simply the type of this interface here. We can cut and paste that. Next we have the properties for the filter. The threshold we'll keep, and we'll get rid of the mix property. Notice that the backing field for the property is serialized, so your filter state will properly save. The next override is a number of filterable channels. As we're making a very simple stateless filter, this filter doesn't need to remember any data, it's just applying a simple algorithm to it. We can filter any number of channels. Then we come to the actual data processing. We get a float array, the index from which to start processing, the number of samples to process, and a Boolean value which tells you if there is any data in this array here. In the case of passive filters, which don't actually need to memorize any data, well, if there's no data, they won't add to it, so we can return false straight away. Returning false means we're telling the caller of this method that we're not adding anything, even though the data is empty. Now we move on to the loop initialization here, and we can get rid of the distortion algorithm and keep the rest. So caching the inputs in the loop body, then we'll just square that input. I'm making a very stupid and rough filter here, but it's quick. And we'll say if input is smaller than threshold, then input equals threshold. Now, as we squared the value, we're only getting positives, so if the original data was negative, will restore its sign. Input equals minus input. Then we apply the processed data, sorry, that's the wrong way around, to the array at the correct position. There we go, that's it. And we return true because we did actually process some data. Then you have another method named process chunk that we won't go into for now. This is used if you're filtering multi-channel interleaved signals. You have a stride parameter here that is specified. Then we have a reset filter override. We don't need to reset anything as we're not a sign. We don't need to keep memory of any state. Then next override, get multi-channel wrapper. We don't need to do anything neither since we can filter any number of channels. Then the static constructor, example filter. And here we register to AGAP monofilter, which will keep track of all filters. So we need to pass a name for that filter. That's the name that will show up in the inspector. Don't make it too long. And a type. That's the type of the class. And that's it. Our filter is ready to be added to a G-Audio track. So we'll go to track 0. That's the track through which default audio is routed when you're in the inspector previewing sounds. Now we can find our filter, example F, and add it. I'll bypass it first and just listen to the original sounds. Okay, piano samples. And we can adjust the threshold here. That's about it. We've got our custom filter properly serialized and working in the inspector. If we go to play mode, it's still there at the same threshold value, and we can hear it in all its beauty once again. So sorry for that pretty horrible filter, but it was quick and dirty, and I hope served its purpose into demonstrating how simple it is to add your own filters in G-Audio and get them to show up properly in the inspector. This is a very new feature. If you would like me to extend it, do drop me a note. I'll be very happy to. Have fun with G-Audio, and bye-bye for now.